So let's have a look at precipitation reactions. Now, just to clarify a couple of things, I'm going to use two very similar versions of the same word. If I'm talking about the act of precipitation, I'm going to say precipitate, and that is a verb. If I was talking about the thing which is precipitated out, I'm going to use the word precipitate. Spelt the same, looks exactly the same, and that one's the noun. So there's precipitate and precipitate. Just to have that little bit of clarity there, so keep your ears open. Now, our learning goal here is to understand a precipitation reaction. We want to know what happens. And we should be able to, by the end of this, make predictions using solubility rules and write down these as net ionic equations. So, precipitation reactions. These guys occur when two chemicals in solution react, giving a product that comes out of solution, or forms a solid usually. Now remember, precipitation, snow, rain. These are precipitations. So we have vapor in the air that is a gas, and then it falls out of the air as a liquid or a solid, depending on snow or water. So they're useful for cleaning drinking water, and they're also really useful for getting the highest purity of a solid out of a substance. So if you're looking to purify your silver, etc., gold, this is the sort of reaction you would use. Some ionic substances, ionic substances, when we put it into solution, what actually happens is the electronegative difference between the two is what holds it together. And if it's quite high, they will overcome the polar interruptions of water and not separate out. It will stay as a solid. So an example, okay, sodium hydroxide plus silver nitrate. So if we got sodium hydroxide aqueous, silver nitrate aqueous, when we add those together, we get sodium nitrate aqueous, silver hydroxide as a solid. And that's because the electronegative difference between hydroxide and silver is so great that the polar nature of water can't separate it out. So let's have a look how this actually looks. So we see what's going on. We've got sodium ions. Now we're talking, this is a total ionic equation. Sodium ions and the hydroxide ions are both in solution because they're aqueous. The silver ions and the nitrate ions are also in solution because they are aqueous. When we add them together, we get nitrate ion stays in solution. Sorry, the sodium ion stays in solution, the nitrate ion stays in solution. But the silver and hydroxide ion become the precipitate. They precipitate out of solution and they become a solid. And that's what it looks like over here. Now, that's a total ionic equation. So what we can see is that the sodium and the nitrate here are spectator ions. So if we want to write a net ionic equation, it would look like this. Silver plus aqueous, plus hydroxide ion, aqueous, gives us silver hydroxide. Hope that made a lot of sense. If you have any questions, get it to us in the comments. I don't know why that sounded like a question. And yeah, we'll get back to you as soon as we can. Thanks for watching. Bye now. One thing I forgot. Solubility rules. Solubility rules are really important. So this is how we make predictions. So you'll get a table like this. Might even be this table. And from this we can look at the ion. If our solution has a nitrate in it, we know that all nitrates are soluble. But, calm down a bit. We have chlorides, bromides, and iodides. All chlorides, bromides, and iodides are soluble. Cool. Except silver, lead, and mercury. And this is why we had that solution came out. Hydroxides, actually no, hydroxides had to do with this. All hydroxides are insoluble except those of sodium hydroxide and potassium hydroxide. Barium and calcium are slightly soluble. So what this means is, if we have sodium hydroxide, we can use that to pull, say, the silver out of something or the gold out of something if it's in solution. Now that's the end. I hope that made sense. If there are any questions, put them in the comments. We'll get back to you as quick as we can. Thanks for watching. Bye now.